Master artists of the Renaissance period used a grid in the form of a wire mesh as a tool for breaking up the components of the subject that they painted. See the football coach. He is using a similar grid to pinpoint locations of players on the football field and to plan his strategy for the game. Using a similar method, you can locate points on a two-dimensional geometric figure with the help of the Cartesian plane. In this lesson, you will learn about the Cartesian plane. You will also learn how to use this plane to plot points. At the end of this lesson, you will be able to define the Cartesian plane, identify the x-axis, the y-axis, the origin, an ordered pair or coordinates, and the quadrants. Locate a point on the Cartesian plane and define the general form of the equation of a line. The Cartesian plane, named after the mathematician René Descartes, is a plane with a rectangular coordinate system that associates each point in the plane with an ordered pair, x, y. The Cartesian plane is often used in graphical representation of figures. For instance, look at the football field again. How can the coach determine the position of a player P on the field? We can resolve this problem by regarding the football field as a Cartesian plane, which is represented as a graph. The length of the field on the Cartesian plane is the horizontal line xx dash, and the breadth of the field is the vertical line yy dash. Yy dash intersects with xx dash at point O. The horizontal line xx dash is the x-axis of this Cartesian plane. The vertical line yy dash is the y-axis of this Cartesian plane. The point of intersection of the two axes, x and y, is called the origin O. On the Cartesian plane, the position of a point is represented as the distance along the x and y axes. For instance, the coach has placed player P on a certain point on the plane. The coach draws perpendicular lines from point P to the x and y axes. Point P is represented as P x, y. In point P x, y, x is called the x-coordinate or abscissa. Abscissa is defined as the value of a coordinate on the horizontal axis. Similarly, y is the y-coordinate or ordinate. Ordinate is defined as the value of a coordinate on the vertical axis. Thus, x, y is called the coordinates of point P. In a graphical figure on the Cartesian plane, a point on the x-axis has the coordinate x, 0. Therefore, if player P is placed at a point on the line dividing the football field vertically, the point is represented as P x, 0. Similarly, any point on the y-axis has the coordinate 0, y. Therefore, if player P is placed at a point on the line dividing the football field horizontally, the point is represented as P 0, y. Let us now see how we can represent different real numbers on the x and y axes. Since the point of origin represents the 0, 0 coordinate, a point to the left of O will be negative, and a point to the right of O will be positive. Therefore, OX represents positive real numbers and OX dash represents negative real numbers. Similarly, OY represents positive real numbers and OY dash represents negative real numbers. XX dash and YY dash divide the rectangular field into 4 equal parts. These parts are called quadrants. Thus, quadrants are the 4 parts of a plane created when the plane is divided by 2 perpendicular coordinate axes. XOY is named as quadrant 1. In this quadrant, x coordinates as well as y coordinates have positive values. Thus, this quadrant is of the type plus, comma, plus. X dash or Y is called quadrant 2. In this quadrant, X coordinates have negative values and Y coordinates have positive values. Therefore, this quadrant is of the type minus, comma, plus. X dash or Y dash is called quadrant 3. In this quadrant, X coordinates as well as Y coordinates have negative values. Thus, this quadrant is of the type minus, comma, minus. Y dash OX is called quadrant 4. In this quadrant, X coordinates have positive values and Y coordinates have negative values. This quadrant is of the type plus, comma, minus. Now, based on your knowledge of the Cartesian plane, can you identify the coordinates of the player P on the football field? Refer to the perpendicular lines drawn by the coach from point P on X and Y axis. The lines meet the X-axis at 3 and the Y-axis at 4. Therefore, the position of the player P is at 3, 4, which lies in quadrant 1. You can use this method to determine the coordinates of any point when you're presented with data in graphic form. For example, the coach places another player Q on the field. To determine the position of player Q, draw perpendicular lines from point Q to the X and Y axis. The lines meet the X-axis at -5 and the Y-axis at 4. Therefore, player Q is positioned at -5, 4. Similarly, you can determine the positions of other players at various points on the field. Let us continue analyzing the positions of players on the football field with the coach. Assume that at some point of play, the positions of the players are at 0, 5, 0, 3, 0, -2, and 0, -5 on the field. If you join all these points, you get a line which coincides with the Y-axis. This is because all these points lie on the Y-axis where the value of the X coordinates equal to 0. In other words, the equation of the Y-axis can be written as X equals 0. Let us now consider a situation where these players are in a straight line at a constant distance k from the Y-axis. You will notice that the line joining the position of players standing at the same distance actually runs parallel to the Y-axis. For this line, the distance of the players on the Y-axis is constant, that is, X is equal to k. This means that the coordinates of these players will be k, 5, k, 3, k, -2, and k, -5. Therefore, the equation of a line parallel to the Y-axis is X is equal to k. Another situation may involve positioning the players at -6, 0, -3, 0, 2, 0, and 5, 0. All these points lie on the X-axis and the Y value is 0. Therefore, the equation for the X-axis in this case is Y equals 0. Additionally, if you notice, the line joining the position of players standing at the same distance actually runs parallel to the X-axis. For this line, the distance of the players on the X-axis is constant, that is, Y equals k. This means that the coordinates of the players will be -6, k, -3, k, 2, k, and 5, k. Therefore, the equation of a line parallel to the X-axis is Y equals k. Let us now consider all the equations together to arrive at the general formula for a line. The equation of the Y-axis, x equals 0, is represented as x plus 0y equals 0. The equation of a line parallel to the y-axis, x equals k, is represented as x plus 0y equals k. The equation of the x-axis, y equals 0, is represented as 0x plus y equals 0. And the equation of a line parallel to the x-axis at a distance k is y equals k, is represented as 0x plus y equals k. Therefore, the general form for the equation of the line is ax plus by equals c, where a, b and c are real numbers, and a is not equal to 0 or b not equal to 0.